Sometimes math gets a bad rap for just having formulas memorized and then plugging numbers into formulas, and it's just not really a fun process. You don't really get into it or understand it as anything above that. And what this looks like is just kind of probably the same, but the fun thing is here is that if you can figure out how quickly in angular velocity a wheel is turning, let's say like here it says it's 15 radians per second. 15 radians per second is an angular velocity, because remember when we were on the stage and we were turning, we wanted to make 2 pi radians in 5 seconds, or maybe 4 seconds depending on which class you were in. But here we're going 15 radians per second, and so that is this fancy W called omega. That is angular velocity. Now there's another formula for linear speed, that is the distance or rate these going forward. Linear speed is angular velocity times the radius of the wheel driving it. So in this case, linear velocity is simply 15 radians in 1 second times the radius of the wheel. Now the radius of the wheel, we have to be careful because they give us 26 inches here, but that's the diameter. So the radius is a 13-inch wheel. And so if we just multiply this out, 15 times 13, we basically get 195 inches per second. Okay, and that's the answer to this first part. This first question says well, it isn't either. It says find it in feet per second. So let's take one conversion here and get inches to feet, 12 inches in a foot. And now I'm going to multiply 195 times 1 and divide it by 12. So it's 16.25 feet per second. Okay, that's one answer. But we're not even really done there. If we want to get to the second answer, we want it in miles per hour. So now we're going to make 2 more conversions. We're going to get feet to miles, 5,280 feet in a mile. And while we're at it, why don't we get seconds to hours? And there's 3,600 seconds in 1 hour. So notice the label for seconds had to go on the top since it was on the bottom before to cancel out. The label for feet went on the bottom because it was on the top before. So now we just do the math there, 16.25 times 3,600, and then divide by 5,280 essentially. So it's about 11.1, I guess. I don't know how accurate we needed to be. Yeah, approximate. So about 11 miles per hour. Kind of a fun problem. Definitely realistic. You could figure all of that out with your own bike, how fast you can go.